everyone, and welcome to this part one of our series on Docker for Cloud Academy. So this first part is titled Docker from Idea to Development. Right, so the goal for this webinar is to mostly familiarize you with Docker. I'm hoping that most of you maybe have heard of Docker, maybe seen something but never actually used it, and are trying to get some ideas on how you can get started using this technology, maybe some first steps to maybe start some adoption in your company or your organization or team. So we'll start out with a short presentation, and then with the remaining time that we have, we'll do a demo. So I'm hoping that the presentation gives you enough sort of information to get going, and I think that the demo will crystallize some other concepts. And then after that, we'll spend whatever remaining time we have for Q&A. So please type your questions in the chat, and at the end, I'll find the best ones and answer them. And if we have a ton of questions, which I'm hoping we do, given that there's 200 people here, I'm sure that we'll have plenty of great questions. We'll do our best to triage those and answer those in the Cloud Academy Community Forum. So check back there afterwards. Also, as a complement to this session, we will provide a blog post that summarizes it. So if you like the video, you have that, and you can also reread the summary in text form. So that's a bit about the webinar. This is, again, part one of a three-part series. Part two will happen sometime in November, more on deployments, and then part three will happen in December. Okay, so moving on, a bit about me. My name is Adam Hawkins. I run the Site Reliability Engineering team at SaltSite, where we manage roughly 350 Docker containers in our production environment. And we've been on Docker for quite some time. Myself, I've been using it for over 2 years. If you've also seen, I've put together this Introduction to Docker course on Cloud Academy. You can find me on Twitter at adman65, and there's a link to my blog afterwards. So if you have any other questions about the content of this webinar that's not answered on the, in the session or on the forum or in the blog post, don't hesitate to tweet me or get in contact with me. I'm happy to answer all of or any questions that you have. I mean, the goal here is to get you educated, so don't hesitate to reach out to me if you have something you want answered. So we're here to talk about Docker and friends. So Docker is a whole ecosystem at this point, and hopefully this webinar will demystify some of the components, get you familiarized with what's going on. So let's move on to a quote from Docker itself. So Docker containers wrap a piece of software in a complete file system that contains everything you need to run: code, runtime, system tools, system libraries, anything that can be installed on a server. This guarantees that the software will always run the same, regardless of its environments. So in a nutshell, what we have is application images and a way to distribute and run those images. So let's go a bit deeper into what we can actually do with this technology. This is a bit abstract, but turn it into something a bit more concrete. So Docker builds itself really as a tool to build, ship, and run applications. So I've divided up some of these use cases up into these two different areas. First, build, which is more like development, which is more the content of this webinar. And then also ship and run, which is more for production. We're going to talk about both and mention the production side to get you sort of acquainted with where this stuff is going and what the progression will be for you. So to give you an idea also where you can kind of branch out and look around. So the first one up is development environment automation. So it's quite common that we have, as engineers, more complex environments. So let's say that you're building a C program. You'll have a bunch of libraries and other things installed on the system. This can be packaged up as a Dockerfile. We'll talk about this also later, and committed to source control. Now, every team member will have the same environment independent of their own system. So it's a great way to control these dependencies and the other things that you may need. You can also use it to actually manage your data stores. So let's say that one project depends on database version A, say like Mongo 2.8, for example, but another project depends on version 3. So running both versions may not be possible with your package manager. However, it's trivial to start a Docker container for version A and version B, then point the application to talk to these containers. So I know this was a big problem for me actually when I was a consultant, and I was working for one company and they actually needed database version A. And working on another project, I needed version B. I didn't have virtual machines at the time, so I had to coordinate this process. But now this can be really useful in a development environment, especially when we deal with more microservices applications and different databases or different applications may have their own data store requirements. So we can also focus on cross-application development. I don't know how many of you are dealing with, say, environments where your team or even yourself are maybe switching between OS X, Linux, or even Windows. But consider that sort of team. Building an application on each platform will create many problems. So instead, you can package up the application as a Dockerfile, and each team member will always run the same thing. I mean, this is especially a big deal if you're dealing with Windows. Luckily, I never had to do that, but I know how much of a pain it can be. And then probably the biggest one of the most useful applications here, is development and production parity. So given that in the development environment, we may use Docker to build our application, we can take that image and ship it off into production. So we can use that even across other environments. Say you can push one image, you can use it in development, staging, QA, like UAT, acceptance, any of these other environments that you have. And you can be confident that regardless of along the way that you're always using the exact same artifact. So now let's move on to the ship and run applications. So I'll be clear with you, this is sort of my favorite topic, so I'm kind of slanted in this way, but standardizing your production infrastructure is a big one. So this is a really massive thing. So given as more and more teams and organizations move towards building more distributed services, they're going to be, say, using language A, language B, just an explosion of polyglot environments. Now, say, your developers, your operations team, infrastructure engineers can, say, build a single infrastructure that can just run Docker containers. So this is a big thing, and this is a big part of this series we're going to focus on in part 2. So CI build isolation. This is another useful thing. So CI systems can be fickle. Each project may change the machine in some way. You may need to install some random software or drop out artifacts everywhere. Also, don't even get me started on each project and their own dependencies. Like if one person on the team is building a C project, you have a compiler, all these other things. Whereas if people are building a Ruby application, they need to have tools X, Y, and Z, and maintaining all of the configurations to support each of these different software stacks can really be a big problem. But all these problems are actually a thing of the past with containers. So we can run each build in a container where that process, say, has root, and it can set up and install whatever it needs, then it can do all the steps, and then we just throw away the container afterwards. There's no fuss and no muss, and most importantly, there's no impact on the host system itself. Next up is testing new versions. Or testing new software. So it's a happy day, right? You get new software, you test it out. But the new language, like the new version of Language X was just released, and now you want to migrate something. Say you want to test going from Ruby 1 to Ruby 2.2. So you just want to test it out, but you don't want to set up a whole new virtual machine, maybe not to break your existing setup. And this is also, say, a resource and time-consuming process. Docker makes this quite simple. You can simply change the image tag in your Dockerfile to, say, Ruby 2.1 to Ruby 2.2, run your program, and see what happens. We're going to come to this later on in the demo. One other useful use case that I've come across is actually distributing new software. So let's just say that you've built a tool in Language X. Let's call it Ruby, for example. Unfortunately, some of these languages have a bunch of dependencies. I mean, not everything is, say, Go, where we can compile it down to a single binary. But now we can distribute the software as a Docker image, and now anyone with Docker can run our software irregardless of whatever it was built on. So containers and images and this stuff is not necessarily just about production. It also can be a great way to distribute software, say even the internal tools you write. So you can build a Docker image, push it to the Docker registry, and anyone can pull down your image and run your software. This may be especially nice for handling builds over to your QA team. So that sort of covers what you can do with it, but what actually is this? Like what is the technology that we're actually talking about? So Docker itself is really built on a bunch of key technologies in the Linux kernel itself. One of the big ones is control groups. So when we talk about Docker and Docker containers, when you start a container, you can set say a CPU limit, memory limits, I/O limits, network limits, these types of things. So we'll come to this later, or more on this later. So one of the other things is that we talked about it a little bit earlier, but this is really, say, all about process isolation, right? So I can have application container A running that has its own set of users, its own set of file system mounts, all sorts of things. And then I can have application B container running, and they don't have access to, there's not shared state between those two things unless it's explicitly declared. So given this is sort of an introductory webinar to the technology, I want to clear up one of the big sort of common things that's used to describe Docker for people who have not come across it before. So it's common for people to say containers are lightweight virtualization, but this is actually just not true. So this image is actually taken from the Docker homepage, and on the left we have an example architecture for virtual machines. And on the right, we have an example for containers, in this case, specifically containers driven by the Docker engine. So in the left case, we have a virtual machine, we have a separate hypervisor. So we have multiple kernels in this case. We have the kernel of the guest or the kernel of the host system running a hypervisor, and then each individual virtual machine has its own kernel and a separate set of resources completely on top of that kernel. But now when we talk about containers, we have multiple processes all running on a separate kernel. My bad. We have all of the processes running on a single kernel. So this is one term that you will come across as actually something to say operating system level virtualization, not necessarily hardware level virtualization. So when we talk about virtual machines, if we are, say, running 10 virtual machines, we need to dedicate, so much RAM, so many CPUs. And all these compute resources really add up. When we talk about containers, we're actually able to more effectively share some other resources on the host system and get also a very useful level of isolation and abstraction. So hopefully that clears it up. And if you have any more questions on this, throw them in the chat and hopefully we can discuss them afterwards. So now we can talk a little bit about the Docker flow. So the usual process for this is we first start out with Docker build. So we can talk about the Dockerfile and what it means to actually build images. So we built an image, and that is then creates an artifact that includes all of the dependencies, anything that we need to actually, say, run our particular application. This could be source code, any sort of configuration files, anything like this. So next we would say push this image to a registry. In this example, we would push it to the official registry, which we can use to share on public images, but you can also create a paid account on the official registry if you don't want to run your own to share private images. So next, the big one is actually run. So this will actually take our image and start a container. So I also want to clarify one thing, that when we talk about images, these are just the artifacts that can be used to actually start a container. A container is a running instance of an image, so a process has actually been started. images themselves do not map to, say, processes or anything like that. So colloquially, when people talk about like Docker images and Docker containers, it's more correct to actually say, I built an image and now I use that to start a container, if that makes sense. So that's the high-level flow. The next step we're going to go through is, what does it actually mean to build a Docker image? So here we have a sample Dockerfile I put together. I'm going to quickly read through sort of the high-level structure of this, and then I'm actually going to minimize the screen so I can use the tools in the webinar to highlight some sections. So first up, we have from, which declares which image to start from. So this is what you call your base image. So in this case, we say use Ubuntu, and then the colon followed by a tag. So images can have their own tags. So for example, we might have Ubuntu 14.04, 16.04, any other versions. You can create as many tags as you want to. Next, we can use run to run arbitrary commands at build time. So in this case, we have a Node.js application. So I'm going to start by updating the package repositories, or updating the local package cache. So when the next line happens, apt-get install, we'll pull down the correct package and install curl. All right. Next step is to actually use curl to install the package repository for Node.js. And then the next step is to install Node.js. This is sort of the structure that you'll see: declare a base image, install your dependencies, install your packages, things like that. Next thing would be to say copy over your source code. So in this case, I only have one file, server.js. We're going to copy that file from the build directory into the root directory into the Docker image. The expose command, say, lists a port to expose when starting this image. So in this case, we have a hello world server in Node.js that will start on port 8080. So in this case, we say expose port 8080. This way, when the Docker engine starts our container, port 8080 will be exposable to other containers. And finally, on line number 13, we say give a default command. This is the one used when we start the container without specifying a command. This we'll see more in the demo. We're going to go through this also in the demo. So we covered the, like say, base images and pushing images. So at this point, we have to actually talk about the official registry and the official library. So the official registry is the default place to push images. So when I write something like Docker push, say foo, it will go to the official registry. And when I run Docker pull foo, it will look for foo on the official registry. And you can, of course, change this, and you can run your own registry. So let's say that you're operating in an environment where you have some sort of requirements that don't allow you to use something like that. You can run your own registry in your own data center or inside your private network or things like that. So there is really a ton of useful base images in the official library. So in the official library is a set of images on the official registry. So in the previous example, we saw the base image called Ubuntu. This is an official image because it does not actually include a slash. So the images in the official library really cover, I would say, 90% of the most common use cases and common applications. So the other 10% is from user-contributed images. So there is really a large amount of high-quality images in the official library, but I know, say Kafka, for example, doesn't have an official image last time I checked. but there's plenty of user-provided images on the official registry that are public, so you can just pull them down and use them. So where this starts to really shine is that there's a base image for pretty much any language that you would need. So there's Python, Ruby, Node, Java, Go, and more. And more are coming every day. The images as part of the official library are actually user-maintained, and then Docker selects the best ones and then copies them over into their official account. But it's not actually just for languages themselves. There's also images for data stores, and this is really where this starts to become quite powerful. So there's an image for Redis, MySQL, MongoDB, all of the sorts of common ones that you might interact with on a day-to-day basis. So where this starts to become really powerful is you can use some of these some of these official images to compose larger applications. And this is exactly where we're going next with Docker Compose. So given that the point of this webinar is to kind of get you from idea to development, Docker Compose is probably the most useful tool you'll see for your development environments, and not necessarily just development environments, but your development workflow, and potentially even your deployment pipelines. So what Docker Compose does is model multi-container applications to a simple configuration file. So let's say that given we're working with a sort of common web application, we'll have one web server process and probably a database. There might be other processes, right? But in this way, we can write a configuration file that says, I need a container running this image. I have this container that's running this image. These containers depend on each other, and they can be interlinked, and they can do networking. So I just saw there was a question in the chat regarding networking and communication between containers. I want to talk about that also a little bit in the demo. So Docker Compose really is great for development and testing, especially if you have more complex application with multiple containers. I think for some of the stuff that we use at SaltSide, we have maybe 5 or 6 containers for one application. So it really simplifies some of the orchestration and grunt work around working with these things. And you can even actually use this to deploy to staging and production. So Docker itself uses a client-server model. So when we use the Docker command, we're actually invoking a client that talks to the Docker daemon or Docker server. The server may be local or remote, right? So in this case, you can say have a Docker host on some other machine. Then you can change your client to talk to, say, your staging Docker machines or your production Docker machines, things like that. We're also going to see this in the demo. This is where Docker machine comes in. So Docker machine creates Docker hosts. So this is a new term, and it's important to understand. As I mentioned before, Docker uses a client-server model. So a Docker host is a machine that is running the Docker daemon or the Docker server. So I can put my Docker client to it and execute Docker operations. So Docker machine is a way to bootstrap these new Docker hosts. So I can create them locally using VirtualBox, or what's the other virtualization one called? I can't remember the other big player. And I can even create them on the cloud. So you can use Docker Machine to create, say, a Docker host for staging, for QA, or for production on Azure, AWS, Rackspace, DigitalOcean, pretty much anything you could think of. And you can even create machines for a Docker Swarm. This isn't really part of the scope for this webinar, but it's something that we'll talk about in part 2. But Docker Swarm is Docker's first-party orchestration, sort of a way to combine multiple Docker hosts into a single place where you can run groups of containers. So we talked about some things. Now it's time to actually put those into concrete terms with the demo. So what I would like to do in this demo is first let's build a Docker image and start the container. let's play with Docker Compose and see what other miscellaneous features and things like that we can cover. So I'm going to switch over to the terminal now and run through some of the things that I've showed earlier in the presentation. So I hope that's okay. If not, just write so I can zoom in. So what I have here, let me just change into the prop1 folder. So what I have here, I'm inside a virtual machine where I have Docker installed. So right now I can write something like Docker PS. That's to show me that I have one container running. This was something that I was doing before the webinar, so I can see I have this Node.js server. So the first thing I'm actually going to do is just stop this container. I need to get things into a clean state before we can quickly run through some of this stuff. We'll come back to what these commands are actually doing after I get a little bit farther through the demo. Okay, great. So now if I run Docker PS again, I'll see that I have no containers running. So Docker PS is somewhat like the PS command you have in Linux, right? It will tell you about all of the containers, what image they're using, the container ID, what their state is. So now that we're in a clean state, we can start off with what I wanted to show you. So the first thing was to actually build a Docker image. So let me pull up my editor, and I'll show you I have this simple server.js. So there's not really much going on here. We're just going to require HTTP. We'll create a web server that says hello world, and then start it on port 8080. So as you can see, this was the same Dockerfile we covered earlier. So now I will build this application, or build this image. So let me just in a little bit so we can get this loud and clear. So now you can see I'm in my directory where I have this Docker file. So I can write docker build -t. So T is the image and tag. So in this case, I'm just going to call Cloud Academy Docker Webinar. The next argument is the directory to use for the build context. So when we saw like copy server, this is the directory where the files can be copied from. So now I can hit enter and build this image. So this actually completed really quickly because I had actually built this image before we've done the demo. So it's only going to build it again if nothing has changed. So now that I have my image, I can actually start this container. So the way we do this is through Docker run. So there we go. So we could say Docker run, and then we give it the name of the image to run. In this case, I will take this. Just realized the spelling is incorrect, so it's a good thing that I copy and paste it. Now, let's start it. Now, it says the server is listening. We should be able to talk to this on port 8080 as we expected. So let me go back to my other terminal where I'm inside the virtual machine. I'll try to curl localhost port 8080. Aha, okay. But now we get failed, cannot connect. So what's going on here? So it's actually because by default, you can only do inter-container networking. So if I had another container, I could talk to this one. So what I need to do is come back over here to this place Eek. Okay, we'll stop this container. Actually, we'll do kill to, okay, there, it died. Let's just stop it anyway. And then docker rm. All right, so what we actually need to do is expose a particular port. So in this case, what we need to do is say docker run with the -p argument. This is for exposing ports. So in this case, we can map port 8080 and the container to port 8080 on the host. So now if I start this up again, okay, server listening. Now if I do curl to localhost 8080, there we go. Now we see hello world. So I want to also demonstrate some of the life cycle of these containers. So you saw me execute docker stop and docker rm, these sort of things. But the life cycle for a container is that it's running. So now if I run, let me zoom in on this window so we can see the whole docker ps. So if I run docker ps, I can see that now I have this container ID, it's using some image, and the status is up. So naturally I can take this container ID and then run docker stop. This is kind of equivalent to running the kill command, or yeah, kill. This will do its thing. And then over here, you can see that the container or the process has stopped. So now if we check docker ps, we don't see anything. But this is actually misleading. We actually want to do docker ps-a to show everything. Now we can see that this container exited. But now we can actually start a new container again. Now, if we check docker ps, it's back. And you can see that we have our ports still there. And I can curl localhost 8080 and get hello world. So the containers aren't actually gone until we remove them. So in this case, you want to say docker stop. Let's get the container ID. Now let's go to, let's remove this container. Now if we check docker ps, there's nothing there. If we do docker ps-a for all, there's nothing there again. So that's sort of the very basic stuff regarding working with these containers. But now I want to show off just a little bit of what we can do with the official images to make our life as developers much easier. So this bit is a bunch of grunt work, right? Installing curl, installing dev repository for Node, and then installing Node. I mean, what we really want to have is just something that gives us Node. So we can just do this and change the base image to, instead of Ubuntu, just say Node version 4. And now we can say docker build -t, let's spell it correctly this time, academy webinar. And so now in this case, let me zoom in a little bit, you can see that this is the first time that I'm actually using this image, Node version 4. So now it's pulling it down, and this will include everything for me. So hopefully this doesn't take too long. Then we can show some things around Docker Compose. But this stuff is actually, I mean, really powerful. So you can if you're working with any language or you just want to ship your application, you really just need to set the base image, maybe install some extra packages that are more application specific, copy over your code, and then you're good to go. There's much less stuff to, just much less to maintain. So let's zoom out a little bit. So now that I've built this image, I can start it again. So let's take this. Now we can, of course, curl on localhost 8080. And it works. So got to remove a nice bit of amount of lines, and it's more straightforward. So there really are images, base images for all of the languages that you will be using. And it's really nice. There's also this on build, which I suggest you check into. So that can automate even more stuff around, say, installing dependencies and things like that. I advise you to check that one out if you have time. So now that we've covered just a little bit around, say, building images and working with containers, I want to demonstrate Docker Compose and how we can, say, communicate between containers a little bit. So I have created a simple Docker Compose file. Now I will zoom in on this so everyone can see. Okay, so with Docker Compose, you have to declare the version of the configuration file, and then you list these services. Now, the services roughly map to, say, containers. So in this case, I declare that I have a container called server. It's going to build the image from dot, which is the current directory, and it's also going to expose port 8080. We will also have one container here called DB, which is actually going to run Redis. So let's zoom out of this window and show a little bit about Docker Compose. So we'll come back over here to this one and say Docker Compose up. And what this will do is automatically start all of the containers we have listed in our configuration file. So let's zoom out. I'm going to zoom in on this terminal window, and you can see that it has started the DB and the server. And it's given us all of the logs on standard out. So here's the logs for Redis, and then this little itty bitty line down here for server. So now that everything is actually running in the, we can't really do much with these containers. So containers themselves can also be started in the background. So let's just stop these. I'll start this in the background and then demonstrate how we can do some inter-container networking. We can do up-D, and that will start everything in the background. The same commands that we had with Docker, we can have with Docker Compose. So in this case, we can say Docker Compose PS. This will give us some output about all of the containers we have listed in our configuration file. We also have, say, Docker Compose logs. We can get a log snapshot. We can also do Docker logs -f to follow the logs. And if we check the Docker Compose help, you'll see there's a bunch of stuff here. So start, stop, restart, up, down, clean, all of that sort of thing. So now let me do one example of this inter-container networking. So in this case, I want to demonstrate how we can quickly just talk from our server container to our database container. So in this case, it's a little bit contrived. Let me clear this. So we can say Docker Compose run. So run will start a new container. So Let's give this -int for attached entered in and allocate a teletype terminal. And we want to say run in server bash. No, yeah, okay. It's by default with Docker Compose. Okay, so now you can see I'm actually in a console in a temporary container. So now what I'm going to do is just apt-get update-y. I'm going to install the Redis tools so we can just execute some commands against this Redis server. So now apt-get install-y Redis tools. Now, in order to demonstrate this, I need to come back to this compose file. So here we have listed a server or a container called server and a container called db. So what Docker Compose is doing is going to orchestrate all of the various networking bits that are built into Docker to set it up that these container called server can resolve a host called DB, and vice versa. A DB could also talk to the server, but wouldn't do that. So now over here, I can say Redis CLI -h DB. So here, this DB is the name of a container. So now I can do my Redis commands. I can say get foo, get nothing back. I could set foo to bar, right? I could do it again, get foo, and I will get bar. So this is sort of a really pared down example of how you can do some inter-container networking. You can talk between these different things. I mean, our hello world application is not so complicated enough to say need a database, but I sort of just put this entry into the Docker Compose file to demonstrate that yes, we can do databases, and we can do some inter-container networking. We can also say depends on, say up here, if we needed to start the server after we started the DB. So we can also model all of the containers in dependency order and things like that. So that's a real quick run through some of the stuff we can do with Docker containers and Docker Compose. Docker Compose is really a fantastic way for working with multi-container applications in development. If you take anything away from this webinar, I hope it's that you should investigate Docker Compose and see how you could use that for some of your development activities. And in the next session, we'll actually focus on using Docker Compose to do some deployment things. So you should definitely check that out. Now, this actually wraps up the short demo that I put together. Now, I think we can move on to some Q&A. Let me see what questions we have here in the chat. Okay, so the first question we had was, okay, do you have a comparison of Docker with VMs? I think that we did cover that, and just to quickly iterate the difference between Docker and virtual machines, I will switch back to the presentation. We can come back to there we go. Yep. So VMs, multiple kernels, hypervisor, containers, single kernel, multiple processes. Let's see here. Going to try to get through as many of these questions as we can. I want to find the best ones here. So, next one is pushing to Docker Cloud the same as Docker Data Center? The answer to that question is no. Docker Cloud and Docker Data Center are two different things. Docker Cloud is a product owned, like a, say, kind of a deployment service run by Docker Inc., where you can connect Docker engines to and use that to run the images that you create. Docker Data Center is a self-hosted solution for running large groups of Docker machines. It's not necessarily the same. I think that one's best covered in the community forum afterwards. Okay. Next, one good question here. How many Docker containers can run on a single host of Docker Engine? And one of the other questions was, what exactly is Docker Engine? That's a very good question. So the Docker Engine is the part that is actually running the Docker containers. This is the daemon that's running on the machine. This is sort of the Docker, the server in the client server model. So how many containers can run on a single host? Well, that's a very good question, and that really depends on how much resources a particular container needs. So if you say that your Docker host has, say, 2 gigabytes of RAM, if your containers maybe only need 100 gigabytes of RAM, don't really need so much CPU, then you can see how you could run, quite a few. However, if you had one container that required 1 gig of RAM, well, then you could run less. So that's really about the limits, the compute limits of your host system and your the needs of the individual containers. Okay, here's a good question. Where is a Docker image stored on a local machine when you build? Is it stored on a local machine or on a Docker server? So this is a good question because it highlights some of the understanding we need to have around Docker and the server, like the client server model. So in my example, when I did a Docker build, my image is actually stored locally because that's where my Docker daemon is running. Okay. Now, if I did a Docker push, that would push the image to an externally hosted registry, and then it would definitely live, say, somewhere else out in the cloud. So in the case where you may not be running the Docker daemon on the same host where you're running the Docker client, then the image is actually stored on the place where the Docker daemon is running. Let's see. Okay. Is there any native performance monitoring for Docker containers? Well, not. So when we talk about native performance monitoring, it's more like, what do we mean? Docker itself, let me switch over back to the terminal. I can show you this. So Docker itself actually has a simple way to get stats. I can do Docker stats. This will stream some of this CPU and memory use. So basically what kind of approach that we take is you can use a Docker API to get some of the stats around the containers measured by the kernel and Docker itself, and then report those out. And of course, you could actually execute in the container and run things like top and IOStat, things like that. All right, let's see here. We have questions pouring in. Okay, can you go over what needs to be installed on the operating system to run Docker development or do the same configuration that I am doing? Question really boils down to what needs to be installed. Now, depending on which operating system you're using, it's pretty simple. So if you're on OS X, you can go to docker.com and look for Docker for Mac. You can download that installer, and that will give you all of the Docker commands. So Docker, I think it also includes Docker Compose and Docker Machine. So it's sort of a one-click installation. Whereas if you're in Linux, like Ubuntu, Fedora, Arch, anything like that, then you'll get those things from your package manager, like say sudo apt-get install the Docker engine. And I think if you can also use Docker on Windows, and that does the same sort of thing. It actually creates a virtual machine running Linux, which runs the Docker engine, and then configures the Docker command to talk to that Docker daemon running in that virtual machine. So how does Docker assign processing power to a specific Docker image? Can that be controlled from the outside? So you can set flags when you do to set CPU or memory and things like this. If we look at the docs for Docker run, say Docker run, help, see, you can set, where did it go? There's flags in here so you can set CPU shares, CPU things. You can also set I/O. You can do CPU quotas, all of these things. So you can set that when you actually start the container itself. Okay, here's another good question. How does load balancing work with Docker? Do you load balance containers? So this, the answer to this question kind of depends on how you're actually running Docker itself, or how you're planning to do this. So Docker, newer versions of Docker actually can do inbuilt round-robin DNS load balancing. Or if you're, depending on your setup, you might have an external load balancer in front of all of the machines that are running the individual containers. Okay. One other question, how do we do build plus deployment? Is it like we have a command inside Dockerfile to check out from version control and another command to run a compile, and when can we deploy? So this is a good question because it sort of gets to the heart of what do we want to do with Docker images and how do we work with these sort of artifacts. So the recommended idea is that you would have your source control, a repository that contains a Docker file, and every time you want to build, you would execute Docker build from that root directory and then copy all of your source code into the Docker image. So hopefully you're not having to do something like a git checkout inside the Docker file. You'd already have those source files available to copy them into the image. And then the other part of that question is, when can we deploy? Oh, the answer, that sort of varies, but the idea would be that for every time you make a change, you would build a new Docker image, and then based off whatever your process is, you can figure out how you want to actually deploy that image. All right, the next question. How can we manage configuration for a different environment using Docker? So this is another good question. So the answer to this is in environment variables. So when you start a Docker container, you can say Docker run, and then you can say -e and set, say, foo equals bar, right? So if you had a Ruby application, maybe you do something like rack-env equals production. Or if you had node, maybe node-env equals production. So you can pass around as many of these E flags for environment variables as you want. What else do we have here? think we'll answer one more and then take the rest in the forum. So this is a good question. As far as I understand, I need to install Docker End on each server I want to run a container on. Wouldn't that be hard to manage if I had a large number of Docker hosts? And the answer is yes, if you were doing it all manually, but hopefully you'd be using some sort of configuration management tool to say you have 10 machines and make sure that Docker is installed. And this can be sort of aided by orchestration tools, which is a great segue into the next session. So in part 2, we're going to talk about from development to production. And there's a lot of questions here around deployments and those sort of things, which we'll talk about in the next session. I'm sorry that I couldn't answer all of your questions right now, but I'll be happy to answer them in the forum after this, and we'll provide a link to that probably via the blog or something like that. But I think that concludes our session today. Thank you all for coming. I hope that you enjoyed yourself and got what you needed. So thank you all for coming, and have a good evening, day, afternoon, morning, wherever it is for you. Thank you.